You get 21 meters per second. So we are talking about a moving object, this car, with a speed of 21 meters per second. When we're talking about speed, though, here, in terms of velocity, really velocity includes the speed of the object, but it also includes the direction. So the fact that we are getting a positive 21, of course, we're talking about direction as far as front, back, left, right. We're talking about a positive and a negative direction. So a positive 21 would mean we're moving in a positive direction. Calculate the acceleration now, A, at t equals 4 seconds. What does this information tell you about the movement of the car? So when we're going to find our acceleration, we are talking about the second derivative of our displacement. There we go. So second derivative would mean the derivative of our first derivative, and that is just 4. When we're talking about acceleration, we're talking about meters per second squared. So we now have an acceleration of 4, again a positive acceleration. We have a positive direction. So what can we say about the movement of the car? Our car is now speeding up. So we'll go ahead and write that here at the bottom. The car is speeding up. We have one more example for you tonight, and I'm going to set it up with you, and then you'll have a little bit of time to work on it and bring your thoughts to class next time. And this one's going to entail a couple more components. So a ball is thrown vertically upwards, and its height above the ground is given by this expression right here. Okay? Think about a free-falling object with gravity. You've probably seen similar equations from physics or from your science class. Here's our equation to represent the movement of the ball that's thrown vertically upwards. At what distance above the ground was the throw released? So here is a key part. The throw was released. What do we know when the ball is in your hand before it is released? What time are we talking about? Okay, so think about the path of the ball that's thrown upwards. What time are we talking about when it's first released? Okay, once we know that time, we can find the distance above the ground, because that is exactly what this equation is representing. The distance, or the height, above the ground is given by this equation. Second, find S prime and state what it represents. We just did a word problem with the car, where S prime really is our V, our velocity. So once you guys find the velocity, just a brief explanation. What does that really say about the movement of this ball that's being thrown? And then find T when S prime is equal to 0. So let's consider that for a minute. If our velocity is equal to 0, when along the path, when the ball leaves your hand and then is tossed upwards, when would the ball actually have a velocity of 0? When would it really have no speed whatsoever? Well, consider that. Think about what the path of the ball would look like if it goes upwards, turns around, comes back down. And then part D, what is the maximum height of the ball? The maximum height, okay, when it goes all the way up and it decides to turn around and come back down, what happens at that point? If we can find the time that would happen, when our max would occur, then we could use that time to substitute back into our height equation, and then we could figure out how high the ball was at the maximum height. But again, C and D are linked. Think about that. When is the speed at 0? When is the maximum height going to happen? Those two are related. And then our last two, these two are going to bring in our discussion of velocity and acceleration. Find the ball's speed. So speed, again, we're thinking about velocity here. And we want to know when it's released. So what time, this was back in part A, what time are we thinking about when we are considering the time it's released? And then we'll be looking at the speed this time instead of the height, as part A was talking about. Then we have this time of 2 seconds and a time of 5 seconds. Find the speed, so find the velocity at these different times. Then I'm going to ask you to do the same thing in the last part. Find the acceleration of the ball at the same time as part E. So find the velocity, and you'll have to find the acceleration at when the time is released, the time it's released, the time is 2 seconds, the time is 5 seconds. Considering both the velocity and the acceleration that you find, figure out what can you determine about the motion of the ball from the time that it's thrown. So as soon as it leaves the person's hand, your hand, whoever, tosses the ball upwards, what is happening to it? Is it speeding up? Is it slowing down? And then see if your work that you guys find actually supports what you would think would happen. If you toss the ball upward, you can try to toss your pencil right now. If you toss it upwards, what happens, right? What happens to it? Does it slow down? Does it speed up? What happens? So go ahead and finish these up. We'll see you next time. Have a great night. Goodbye.